Good afternoon, everyone. Welcome to all AWA members and the guests, and welcome to our webinar this afternoon, Join the Revolution, the AnammoX webinar. I'd like to start today's webinar by acknowledging the traditional inhabitants of the land from where I am presenting today, the Aboriginal people, their spirits and ancestors, and acknowledge the vital contribution that Indigenous people and cultures make to this nation that we all share. AWA, what we have up on the screen here is part of our Strategy 22 as an association and Australia's biggest water network. We share, connect and inspire for our members. We provide information, knowledge, we connect our members with industry and stakeholders, and we obviously inspire for a positive change. I'd also like to thank the AWA principal members for supporting AWA and to present this webinar, and also all of our ongoing events that we bring forward.
Okay, thank you, Tanya, for that introduction, and thank you all AWA members and guests for joining us this afternoon for this webinar. Romain Lemaire will be kicking off the session this afternoon for us. He's our global biological expert for Veolia, currently based in Paris. And Romain has been integral to the rollout of the ANITAMox technology around the world and has been involved in many of our overseas projects, as well as being intimately involved with the rollout of the ANITAMox at the Luggage plant here in Australia. He'll be followed by Justin Todd Hunter of Urban Utilities, who will follow with a presentation on the client's perspective about how ANITAMox has been rolled out at Luggage Point, the challenges that have had to be overcome during the project delivery, and the reasons behind why Urban Utilities has selected ANITAMox at Luggage Point. I'm Karen Shaw. I'm the Municipal Technical Manager for Veolia Technologies. I'm your MC for the session today, and I'm also very privileged to have been involved in the journey at ANITAMox journey at Luggage Point as well over the last quite a few years. I'm going to make the assumption that if you've made the effort to join this webinar this afternoon, then like me, you're a water activist. What I mean by a water activist is somebody that's always looking to improve the way we manage our water cycle through more efficient and sustainable technologies and practices. Water, as we all know, is the lifeblood of our existence, and never more so than today, as we all sit in the midst of a worldwide pandemic, should we be more aware of how important it is to have access to clean water. Clean water to wash our hands is our most powerful PPE tool that we have available to us today in our fight against the COVID-19 virus. Cleaning our wastewater efficiently is an incredibly important part of our role in the water cycle. And today we want to share our story about the introduction of a new and very exciting technology called ANITAMox. Before we move to our two speakers who are going to tell you about the hows and the whys relating to ANITAMox, let's have a quick high-level look at why the technology is such an exciting technology in the wastewater space. First of all, it's exciting because it's new. Everything that's new is exciting. In the life of wastewater treatment, which began before Christ with the Romans, this is a very new technology. The Anammox bacteria upon which the technology relies was not discovered until the 1990s, and we're currently installing the first ANITAMox full-scale side stream project at Luggage Point, which will also be the first full-scale ANITAMox project in Asia Pacific. So from that perspective, we can safely say that it's a new technology for Australia. It's also exciting because it's different. In the mid-18th century, chemically enhanced wastewater treatment became widespread in our wastewater treatment processes and has played a very integral role ever since. Denitrification is a process that has typically always relied on bacteria and chemicals. Today, we will find out why ANITAMox is a new way to denitrify without the need for chemicals. It's sustainable. Not only will ANITAMox reduce your overall nitrogen loads in your effluent coming out of your treatment plant, it's also going to reduce your power consumption, reduce your CO2 emissions, and reduce your chemical consumption at your treatment plant. It's organic. So let's be honest here, the star of the process wasn't invented by Veolia. It's a very unique bacteria. It's provided to us through nature. Veolia has just studied this bacteria and it's gotten to know its likes and dislikes and developed a process around it, giving it a very safe environment and home in which to live and grow and thrive. The fact that we don't need to add chemicals to the process means that it's truly organic. Now this bit I love, it's going to save you money. So I love technologies that save us money. Unlike when you're buying your fruit and veg, you can be pretty much guaranteed that you're going to pay more for the organic version. With ANITAMox, you're actually going to save money at your treatment plant. You're going to save money in your overall OPEX. And these savings can be quite significant depending on the process that you have installed at your treatment plant. The ROI, the return on investment for installing an ANITAMox process, is going to be between 2 and 5 years. So it's going to make financial sense to install this technology at your wastewater treatment plant. It's easy to install. It's quite a simple process. It's one tank filled with media or one tank filled with media followed by a clarifier. It's going to be fairly quick to install and even quicker now, as at the end of this year, we'll have a fully sized commercial biofarm in operation at Luggage Point. So we can take the seed from there to seed other treatment plants around Australia. It's fairly easy to operate. Like all living things, Anammox will have a few basic needs and wants that we're going to need to provide, but with the right monitoring and environment, the ANITAMox process has proven itself to be very robust and relatively easy to operate. And last but not least, the color of the ANITAMox plant will tell you a lot about how your process is performing. Let's not underestimate how great it will be for our operators to be able to look into a tank and have a good idea based on the color on how well the process is doing. So that being said, I think it's time now to move to Romain's presentation, where we'll find out more about why we should all be seriously thinking about adding a splash of red to our boring brown wastewater treatment plants. So I shall stop sharing now and hand the reins over to Romain.
Okay, good morning, everyone. I'm in Europe, so it's early morning for my part. So I'm gonna introduce you to the technology. But first of all, we'll talk a bit about the Anammox by itself and introduce you to the topic before jumping into the process itself. So let's start with what is ANITAMox, and before that, which is the Veolia process, what is Anammox in general? If we look at the wastewater treatment plant, we can see a general layout with your water line at the top and then your sludge line at the bottom. What we can see is when we start having digestion, when we want to make use of all the solid generated through your wastewater treatment plant, what we generate, it's what we call the side stream after the dewatering. And this side stream is very little flow, 0.5 to 1% of the inlet flow of your plant, but represent 10 to 20% of your nitrogen load, which is significant. Ammonia concentration is usually quite high, and COD is very low, as we've made biogas out of in the digester, so the carbon left is little. What it means, and it's even worse or more nitrogen when we add the THP, so thermal hydrolysis, which is quite popular now in Europe, in the US, and also in Australia. And this will just strengthen the side stream with even more nitrogen return, up to 30% of your inlet nitrogen coming through that side stream. The impact of that return is basically we have in a biological treatment line, you're gonna require more oxygen to nitrify that nitrogen load. So bigger blower. You're gonna need also, you return mostly nitrogen, little COD, so you unbalance your C/N ratio. So for the denitrification, you might end up having to add carbon into your system. And then you might put at risk your outlet ammonia and TN discharge limit and maybe get fined or not being compliant all the time. And that's why we developed this ANITAMox process to fit into that reject water, that side stream and to treat nitrogen directly into the stream before it is recycled or returned back to the main plant. So ANITAMox is the name of the Veolia technology using the Anammox technology. If we look now at what it means, or which avenue, which mechanism we are using, for those of you not really aware or knowledgeable about the nitrogen removal, here a slide to remind you what happened. So we have first the nitrification using oxygen to nitrify ammonia to nitrite, and then all the way to nitrate, NO3. And then we have the denitrification going down using COD, external carbon, and to denitrify down to N2. This is on the anoxic condition, no oxygen. And we need COD, carbon. For the Anammox system, so this is the conventional nitrogen removal pathway. With the Anammox, the beauty is we can reduce the oxygen need, and we don't need any carbon. We don't need any source of COD. So now we only need to nitrify to nitrite only, NO2, not all the way to nitrate, but only a fraction or a portion of the ammonia, around 50–55%. And then with the nitrite and the ammonia remaining, the Anammox bacteria will do the job and will convert that to nitrogen gas and do the so-called denitrification, but with no external carbon required, which is really good for centrate because they don't have any COD. And then we can have a full nitrogen removal without the need of carbon. It does produce, as you can see on the slide, a bit of nitrate, NO3, around 10% stoichiometric. So you will see in your plant a bit of nitrate using the Anammox system, produced directly by the Anammox. So to summarize the advantage of the Anammox processes compared to the conventional N removal with nitrification and denitrification. So conventional N removal, big slope to go up to the mountain with oxygen, need a lot of oxygen to convert all the ammonia to nitrate. And then downhill, we need a lot of COD, a lot of carbon to denitrify it down to N2, nitrogen gas. With the Anammox, it's a bit different. The mountain is a bit smaller, so it's more like Mount Fuji versus Uluru for you in Australia. But we need a tiny bit of oxygen or less oxygen because we only nitrify a portion of the ammonia and only to nitrite, not all the way to nitrate. And then with the ammonia left over, we go all the way to N2 with no COD. So the advantage of this is less oxygen consumption, stoichiometric minus 60% saving, no COD requirement, so we don't need to add any carbon, and there is no carbon in that type of centrate. Obviously, less CO2 emission because we don't add any external carbon, and we use less energy for the aeration, and less sludge production as well because that bacteria is a slow grower, and we don't use any heterotrophic bacteria to do the denitrification, which produce a lot of sludge. So there is always some challenge, and why we haven't seen those Anammox before in a normal plant for few reasons. First, it's a very slow, so the challenge number one, it's a slow grower, which means that it's, if we compare between like the main population involved in wastewater treatment plant, we have the COD removal done by a heterotroph, and the growth rate or the doubling time from one bacteria to have two bacteria, it's around the hour, couple of hours. For the nitrification in orange, the nitrifier, we know they're slow grower. So to make two bacteria out of one, it's around the day, 1 or 2 days, based on the condition. When we look at the Anammox bacteria, we're talking about 1 week, okay? So the order of magnitude tell you that this bacteria needs the right condition and the right retention mechanism to stay in the system. So this problem or this slow growth rate can lead to long startup when we want to start up these processes. We are developed a special strategy at Veolia called the Biofilm, and the idea is to pre-seed with some Anammox into the system so we can quick start quicker. We can get up and running quicker. and we can reduce the startup time down to 3 to 4 months based on the project. But keep that in mind. Slow growers, so we need to give the right condition and the right retention of the bacteria into the system. Challenge number 2 with the AnammoX technology is we need, as you've seen, the substrate, the key substrate is nitrite, NO2. We need to make sure all the ammonia goes to nitrite, or a portion of the ammonia goes to nitrite, but not all the way to nitrate. If it's nitrate, the AnammoX can't do anything with it. So we need to keep it to the nitrite level. To do that, we need to make sure that those bacteria called NOBs, which oxidize nitrite to nitrate, are suppressed, or the growth is under control, and we don't have that in the system. We need very good aeration control to produce nitrite and not nitrate, and that's the key for the AnammoX. We need a bit of aeration to go to nitrite, but not too much. The AnammoX don't really like oxygen, so we need to provide oxygen for the nitrification stage, but not for the AnammoX. So it's a very sensible parameter aeration, and for that we have advanced aeration control through the Aquavista services, digital services, and that allowed our AnammoX process, the ANITAMox, to be producing mostly nitrite and avoiding to go all the way to nitrate. So that's the background of the AnammoX. Let's jump into the ANITAMox process now, the Veolia process. So it's based on the MBBR technology that some of you might have heard before, moving bed biofilm reactor, and from Upscaling, which are the leader in that technology and are part of the Veolia family for many years now, based in Sweden. So the MBBR technology is very basic. One tank, it's water coming in, coming out, no sludge edge, because we're using a biofilm technology. So the key component of MBBR is the media, so the plastic media in that case, where the biofilm can grow on different type of media we can use based on the type of the project. But first you have the media. You have one tank, you have media for the biofilm to grow. You have a sieve, what we call a sieve. It's to retain the media, the plastic media, but the water can go through in the outlet. So it's a physical barrier for the biofilm to stay in the tank. And finally, we have an aeration system or mixing system when it's anoxic, but in our case, we need aeration. Stainless steel, robust, coarse bubble, but we can also use fine bubble for some project and for the ANITAMox as well. But, usually it's a robust aeration system. So looking now into the detailed mechanism of the ANITAMox. So as I told you, MBBR process, but if we zoom into what happened on the biofilm, so you see a picture of a K5 carrier with Anammox bacteria, with that red specific color on it. If we zoom into a little square, here we go. We have the media, the plastic media in dark, and then we have the biofilm growing on the top. We have the liquid, the bulk liquid around. If we apply some oxygen gradient, we're gonna create simultaneously in the biofilm an aerobic layer on the out layer of the biofilm, and deep in the biofilm we're gonna have anoxic condition with no oxygen, and that's why it's key to control oxygen. We want enough aerobic zone for the nitrification, but not having the oxygen penetrating fully the biofilm to leave that anoxic layer deep in the biofilm for the AnammoX. So what happened after with ammonia? Ammonia in the bulk will diffuse in the biofilm, will be used by the nitrification, those AOB bacteria, the nitrifier, on the out layer of the biofilm using oxygen. And then the produced nitrite and the leftover ammonia will diffuse further in the biofilm, and the AnammoX will be located deep inside where the oxygen is not present. And the AnammoX will finish the job, convert nitrite ammonia into nitrogen gas. So that's what happened in reality in this ANITAMox process on the biofilm. All that happening simultaneously in the biofilm. So Another big advantage of using this technology for the Anammox process is the combination, as we've seen, of the media and the sieve, mean that we have no risk of losing the biofilm and the Anammox from the system. And this is key, as I told you, it's a very slow grower, so we need time for, we need to make sure that we retain most of the bacteria in the system, and we're not losing the Anammox through the system. So we're relying only on the mechanical separation. So once you have the Anammox on the media, there is no way, as you can see on the photo here, that it can go through the sieve and leave the system. We don't rely on setability, density, and so on. It's a pure mechanical separation, retention of the media. The other good thing about that is when you have a lot of TSS coming in, which can happen when we operate centrifuge on digested sludge. We know all that, but as an operator, and Veolia operate many plants, it's not just a technology provider, it's also a plant operator. And sometimes TSS can go, very high in a short time period when we start a centrifuge, for example. In the case of the ANITAMox, all the TSS coming in will come out through the sieve, and we have no interference with the TSS and the media. So that's a really good thing when you have a big flush of TSS. It will go through the system nicely. So that's the background of the Anammox and the ANITAMox process. So now I'm going to show you when and where to apply this technology, where are the sweet spots. So we've been talking about that MBBR configuration so far, pure MBBR, what's coming, come out, no sludge recirculation. And so this is using that system. We are targeting side stream, obviously, with SBCOD. It's a barbarous name, but it's soluble biodegradable COD to ammonia ratio. This is kind of a key parameter to follow in your side stream or reject water or effluent you want to treat with Anammox. If it's relatively low, so we don't have a lot of carbon compared to ammonia, we use this pure MBBR configuration I've just explained. Conventional anaerobic digester, reject water, no problem. Some industrial effluent as well. Am I losing the sound or no? Hope you can still hear me.
We can still hear you.
Yes, Romain.
Okay, because I had, okay, cool. Sorry, I had a strange noise in my headphone. Just wanted to make sure I was not talking alone. Then some industrial effluent I was telling you. It's compatible with high TSS, as I told you, coming in, very robust and easy to operate. Single tank, what's coming, come out, and it's most of our references so far. We also have an IFAS solution. So IFAS is like MBBR, but in the back end, we put like a clarifier to return some of the sludge. And at the end, we have a mixed hybrid system with media in the tank, but also some suspended sludge, so normal activated sludge, which is recycled. And we have a mixture of suspended sludge and the biofilm with the Anammox. We use this hybrid configuration when this soluble COD to N ratio is higher, when your side stream's got more carbon than usual. So typically we use this configuration for when you have a THP, so thermal hydrolysis process before, as a pretreatment before your digester, because you usually have more VFA, more COD coming out from the digestion. Also for co-digestion system, when we have a lot of different waste, not just municipal sludge, we use this IFAS configuration. So it is a bit more impacted by TSS coming in. So we need to be a bit more careful on how we operate the centrifuge or the dewatering, because obviously now we recycle the sludge. So if we have a lot of sludge coming in, TSS, then it will accumulate in the system. But it's more compact than the MBBR version. So we can, so if we have a problem of footprint or reusing small tank, sometimes we can go for IFAS as well instead of MBBR. We have now references in IFAS, mostly on the THP. So when we have this thermal hydrolysis, we use that configuration, and also for mainstream application. So not just for side stream, but for your normal municipal wastewater, we are starting to use the ANITAMox on this type of stream, and we use this IFAS configuration. So a little slide, not just to highlight the THP reject water, because it's quite specific, and it's been reported that it can be inhibitory. It's challenging type of reject water to treat when we have THP. And just to highlight the risk mitigation and how we address the risk with the ANITAMox. So the main risk that people know when we are treating THP with the AnammoX system is inhibition of the AOB, so nitrifier, and the AnammoX due to the specificity of this heat thermal hydrolysis pretreatment. We have also a negative impact of some of the refractory COD, or also some of the biodegradable COD like VFA, which is higher in that type of centrate, on the AnammoX development. So we have a competition between the AnammoX and the normal heterotroph bacteria. This can lead to the loss of the AnammoX from the system. So we need to have something which retain well the AnammoX. And we can have a bit higher risk also of development of the unwanted nitrifier, the one going from nitrite all the way to nitrate. So these are the four main risks when we are dealing with THP. So now to show you what we have for those risks as a contingency with the ANITAMox. So inhibition, we always provide flexible extra dilution capacity, up to 2 volume of dilution for 1 volume of citrate. Usually we are in 1:1 or 1.5 to 1. We can go up to 2 if there is problem of inhibition. So dilution, COD impact as well. So we use that IFAS, as I told you, configuration to protect the AnammoX, which stay on the media, and the OHO, so the normal heterotroph, will grow. If there is a lot of COD, they will grow happily, but in the bulk phase, in the suspended phase. And that's why the IFAS gives you that possibility to keep the AnammoX on the media. Slow grower, all the fast grower will stay in the suspended sludge. Loss of media, I told you before, media, combination media plus sieve, you've got the ultimate retention system of your AnammoX once they are on the biofilm. And for the NOB, to control the NOB, we have advanced control aeration system using DO, online ammonia, online nitrate, online pH, and we have all the set point being adjusted based on the performance of the system. And we also have, when you use IFAS configuration, an extra knob to control the NOBs is the SRT. So we have the sludge edge of the bulk liquid, and we can control that with the IFAS configuration to make sure the NOBs are not growing too much in the system. So to conclude on THP, just keep in mind that Veolia is not just an AnammoX provider technology, but it's also the only AnammoX provider technology which has a lot of experience with THP. More than 20 years, we've developed our own THP process called Biocelis and Excelis. We are operating many THP plants, and that expertise has been put into the ANITAMox to make sure that we can deal, and we know how to deal with this difficult centrate at time. So finally, before leaving the floor or the mic to Justin to talk to you about Luggage Point project with the ANITAMox, few other reference and case study worldwide. So this is the reference list. Don't spend too much time to read that, but in green, you have the one which are already in operation, up and running, for starting in 2010 for the first one in Sweden. In gray or in orange, sorry, in the middle, 4 which are currently under startup. And in red, the last 6, they are the one which are in design phase or will be starting up later on. And we can see in yellow the one in Australia, in Brisbane, in Luggage Point. Mostly in municipal, few industrial reference as well, and most in MBBR configuration, but some also in IBAS or IFAS configuration. If we look at where it's located worldwide, mostly in Europe, 20 plants are in Europe, 5 in Sweden with our colleague of Anox Galnes, 4 in France, then a bit scattered all over Europe. It's been really successful in the US as well. So the AnammoX cross over the Atlantic to the US, and we have it's a very mature technology over there, and all the utilities in the US are embracing the AnammoX technology. So we have 7 reference in US, and now the AnammoX lately has been doing its longer journey to Australia and to Brisbane. So that's been that's the very exciting actually to be there now. So Denver, just few shot of some of the reference. So in Denver, it's the biggest ANITAMox so far, trading 4 tons of nitrogen per day. So it's a very big plant in Denver, 2 million PE roughly. And you see the photo shot of that plant, and the ANITAMox is basically reusing some of the existing tank just at the bottom here. The MBBR technology is very good to retrofit existing tankage you can have on site. We just need a basin of whatever geometric shape, basically. So if we look at Denver, that's how it looks like. Few Photoshop of the plant we retrofit. So you see the empty plant with the sieve, which been located, the aeration grid, and some mixer. 2 side-by-side reactor. The only specificity of this project is alkalinity was low, much lower than normal centrate, because they're using ferric to dewater. So we have some consumption of alkalinity, meaning that we can't, without dosing extra alkalinity, which we don't have in most of the reject water, but in that plant, because it's limiting, we can't reach more than 75% ammonia removal, and the ammonia in the outlet stay relatively high, around 250, 300 for this project. But if we look at, so this is a graph from the client, from the operator. So in blue, you have the load. So you see the ramp up in 3 months time. Oops, sorry, you can't see now. It's going to disappear. But in 3 months time, we've been able to start trading the design load of 4 tons per day by putting only 5% of the media which were seeded with AnammoX. Okay, so it was a very quick startup for an AnammoX process. So in blue, so we can see now we are at the design load, and in red it's the ammonia in the outlet, and we can see that we are quite high, much higher than what we usually are, around 100 to 150. But it is due to the lack of alkalinity. But it's okay for the client to be around that level. It doesn't want to dose any extra alkalinity, so we do with what we have. Again, in Chicago, again, retrofit of existing tankage. So in this time, it was unused DAF. So we retrofit 4 DAF into AnitaMox. You can see some photos there. The good thing about this EGAN plant is you see that we have, in blue, it's the load again, the ramp up. We start in the ramp up, and after 1 month, the client say, okay, sorry, I've got problem of my digester. We have to shut down everything. We have to put the digester into maintenance and do some operation. So basically, we had almost no flow for 8 months, nothing. But the bacteria, the Anammox, the seed were there. And when we restarted after 8 months, you can see that the ramp up has been really quick again to reach the design load of around 1,000 kilograms per day. Those Anammox are very resilient. Once they're on the media, they can stay there happily, and we store them for more than 2 years. And when we restart, the activity is still there. So it is very resilient once you have the Anammox on the media. And you can see in grid the ammonia removal being around the 85 to 90% ammonia removal on that plant. Again, same plant, you see the ammonia level coming in, fluctuating between 1,000 and 1,400 milligrams per liter. And we always below 200, which is what the operator wanted in his return, less than 200 ammonia, which has been the case for now that more than 4 years. I will show you very quickly independent study. So you can find all the paper on that by Los Angeles County in Los Angeles, the municipality. They've been testing an AnitaMox pilot for more than 2 years for their big plant. So it's a big plant in Los Angeles. It's one of the biggest in the US. The John Water Pollution Control Plant, so 3.5 million PE plant. They're only doing, they don't have nitrogen content at the moment in California, but it will come into force late in a couple of years. So they are already testing technology which could reduce the nitrogen to treat on the main plant. They have that existing digesters, so they wanted to test a pilot, both in MBBR and IFAS version for more than 2 years. And what they've been testing, at the end of that period, they wanted to do what we call robustness testing. And you see 6 scenarios. And what they wanted to do is disturb the system with some scenario you can see, like power shutdown, no electricity for 24 hours, no feed, like you've got a problem with the feed, or no centrate available, or you overfeed by 100% more for 24 hours. What happened? No aeration, over aeration. So we know aeration is a critical parameter. What happens if the control system of the aeration go berserk? You get way more air than you actually require. And also trying excess polymer. We know that polymer can be a bit fuzzy sometimes when you have too much for the nitrification and even the Anammox, and on the oxygen transfer as well. So they tested all that. And what they did is apply that event, you can see at the bottom in yellow, for 24 hours, and then measure the recovery time to go back to the same performance than before the event. And you can see for each of the scenario, the recovery time was around 8 hours, so very, very short, to 1 day pretty much, or a day and a half to get back to what it was. And the more problematic is when you have no aeration at all for 24 hours, or when you have a lot of excess polymer, which can take a bit of time to recover. But basically it shows you the robustness of the system through what we all know will happen in the normal life of a plant, some few hiccups along the path. Second last reference to show you THP. That's one of the first ANITAMox in Sweden, in Växjö. But what I want to show you on that plant is the fact that we retrofit a very shallow tank first, an existing SBR, dosing methanol for reject water, and we revamped that tank, kept the fine bubble into an ANITAMox. Started in January 2012, but then in 2015 the client wanted to install THP, which he did, and basically it was the first Anammox system treating THP, and it's been the case for more than 6 years now. It was in late 2014 actually. It was MBBR. As I told you, it's better to have IFAS. So for 3 years, the system was treating THP with the normal MBBR configuration. And late in 2008 or May 2018, we converted the system into IFAS by just adding one of that small clarifier that the client had laying around in stainless steel, just 5 square meter clarifier, to be able to operate this as an IFAS, which is better for when you have THP. And I will show you in a minute the results. So this is the pre-THP, so normal size stream, treating around 140 kilogram N. So the client didn't have at that time the full load on his plant. So in black, you have the ammonia coming in around 1,000, but fluctuating a bit. And you have in red, the ammonia coming out. So on average was around 90 milligram per liter. So quite low. So that for more than 3 years. Then he added THP, and we kept the MBBR configuration because at the start we didn't know that the client will put THP. So it was MBBR ANITAMox. We had to do 40% dilution, so almost 1-to-1 in volume dilution. We're treating a bit more, 160 kilogram N per day, like all the centrate obviously produced. But the residual ammonia in the effluent was around 160, so a bit higher. And you can see at the start we had few hiccup when we had to, as I told you, THP can be a bit problematic at the start. But it did work in MBBR, but we are a bit higher and it was more sensitive. And then we decided in 2018 to switch to IFAS. And you see that we could increase the load and reduce the dilution as well, which is good because down to only 20% dilution required. And the ammonia in the outlet was low as well, around 100. So that was the first ANITAMox treating THP. The one which are just finishing the commissioning now on THP is in Wales, in Fife in the UK with Wastewater. So it's almost a ton of ammonia per day. and it's brand new tankage. You can see the big photo and a brand new clarifier on the photo there. And starting up late last year. And as you can see here in black is the ammonia coming in blue is the ammonia coming out, and in red is the ammonia removal percentage. Around 1,000 coming in, and the dotted line, so after 150 days we treated all the centrate which was available. So where we had this ramp up period to colonize the virgin media with the seed we put in, and then we'd be able to treat. So we don't have the design load. We have 700 now, 750 as we speak. The design is 900, but we are treating everything which is produced. And we are around 90 to 95 and 80 to 90% ammonia removal. So that's it for me. So to conclude, ANITAMox, it's the Veolia Anammox processes, either in MBBR or IFAS configuration. It's a biofilm system, so we don't rely on any setability or density of granule or whatever. It's robust, and we have ultimate 100% of the ammonia retention in the system using MBBR and IFAS. So it's different than most of our competitors, which are using granules or using density to separate the Anammox than the other sludge. For the side stream application, so it's a very mature technology now, even if it's new for the Australian market. More than 25 reference and more than 150 Anammox system worldwide, not just our Veolia one, but all the other processes. So it's very mature, a lot in the US, in Europe, starting in China, in Asia, and now in Australia, mostly for municipal centrate. But also we can use it for THP when we have a THP pretreatment before that. And in that case, we use IFAS. Also for industrial effluent, when you have to remove ammonia and you don't have a lot of carbon in your industrial effluent. Simple and robust. I talked about that already. And just a little pitch about mainstream activity. So we have been piloting a lot on mainstream application. So how to treat with the Anammox on the mainstream water line, not just the reject water from digester. It is working on the pilot level. We are looking for demo project now in Europe and in the US for industrialization. We know that it's the way forward to be energy neutral, because with that we can divert all the COD can go into the digester. We don't need to keep some COD for the denitrification, as this will be taken care by the Anammox without using any COD. So that's really where we can be fully energy neutral with no co-waste, without putting extra waste into your digester. You can be energy neutral with the mainstream application on the Anammox. Lower OPEX and lower carbon footprint. So with that, I'll leave the floor to Justin. Are you with us, Justin?
So good afternoon, everyone. My name is Justin Todhunter. So I work as a process engineer with Urban Utilities. And I think it's an awesome opportunity that I have here today to present alongside Veolia. And basically my presentation here today, we'll just talk a little bit about our journey along the path to full-scale Anammox scale at Luggage Point, and some of the success we've had so far, and we'll also talk about some of the success that we hope to achieve from its implementation. So just a quick overview of the presentation. What I want to talk about first is just some of the key drivers around the selection or the choice to choose this innovative technology. And that obviously following into some of the current performance of our plants, and then also a little bit more about the treatment strategy at our largest treatment plant, at Luggage Point. And finally, just a bit about the upcoming project, or the current project of the AnammoX at Luggage Point. So who are we? So Urban Utilities was formed in 2010. So this followed the merger of 5 councils, and we provide water and sewage services to about 1.4 million residents. So we currently own and operate 28 treatment plants across 5 separate councils. And with the majority of our treatment plants falling within that Brisbane River catchment. And so the effluent from a lot of our plants end up within the Moreton Bay region. And so why is this important? So Moreton Bay is an environmentally significant area. It supports a vast array of marine life within South Sea Queensland. And it also has a significant economic value in regards to recreational and commercial use. And therefore, managing nutrient emissions from our treatment plants, specifically nitrogen and phosphorus, is an important part of our role in maintaining the health of the bay. So with the expected population growth within the catchment area, changes in catchment characteristics such as industry loads, water use profiles, urban utilities face ever-increasing pressure on balancing these nutrient emissions, operational costs and treatment capacity. And ultimately, these pressures are reflected in the cost of the customer for providing these wastewater treatment services. And so with these key drivers, we really have to look at alternative nutrient strategies to enable improved outcome for urban utilities, its customers and the environment. So introduced in 2016, the bubble licence was the first of its kind for the Lower Brisbane River catchment. So compared to traditional effluent limits for individual STPs, the permit allows urban utilities to operate 9 of its treatment plants under a combined annual mass load of tidal nitrogen and phosphorus. These 9 treatment plants obviously discharge within the Brisbane River catchment into Moreton Bay. And so the implementation of the bubble licence has since presented both a risk and an opportunity to achieve greater emissions by shifting our attention from smaller, more costly treatment plants to focusing on focusing on the performance of larger treatment plants. So as you can see, under the bubble licence, our largest treatment plant, Luggage Point, contributes significantly to the total nitrogen mass load. And so its performance heavily influences our ability to meet our regulatory limits and also achieve our strategic goals. And whilst there have been opportunities and we're working towards optimising the performance of our plant, with increased catchment growth, these optimisation works really end up in diminishing returns. And so there's still a shortfall. We're still seeing a shortfall against our strategic target of a 10% reduction by 2023. So as I mentioned, Luggage Point is our largest municipal treatment facility. It treats flows based on equivalent population of about 750,000 people. Being the largest of the 9 treatment plants within that bubble licence, it contributes significantly to the overall TN mass load. And the population growth within the area is expected to increase significantly to about 900,000 EP by 2041. So whilst there are options to meet these effluent targets through significant capital and operational investment, most of these traditional options conflict with our strategies of sustainable treatment due to the increased cost of the customer. So urban utilities conducted an option assessment, and we identified the opportunity to significantly reduce the TN load, or the nitrogen load, to the mainstream process by treating the side stream separately with AnammoX. And as it's well known, the side stream can contribute from around about 12 to 15% of the mainstream's TN load, and therefore contributes significantly to the plant's operating costs and nutrient footprint. So this technology was selected due to its ability to shortcut the nitrogen cycle using nitrite as electron donor and without the need of additional carbon. And by taking advantage of this cost-effective biological process, it's a lot more favourable than other capital or chemical-intensive solutions such as ethanol use. Furthermore, this technology also supports the importation of co-digestion products to also increase our gas and energy production on the site. And although the side stream loads are expected to increase with this importation, the efficient treatment through the AnammoX process ensures this strategy is sustainable on return loads to the mainstream process, and also further facilitates our shift towards a long-term sustainability. So since following its selection as part of the upgrade strategy for Luggage Point, this AnammoX project has really become an important and strategic priority for urban utilities as it aligns strongly with our values, supporting our staff by giving them new technologies and upskilling and various technologies. And also it gives us the ability to manage our nutrients more efficiently to produce better outcomes for the environment. And finally, by reducing costs, we can provide better outcomes for our customers, and also being able to add products and services for our commercial customers as well through that importation of additional co-digestion products. So where are we at currently? So it's been a long process, but we're currently in the process of delivering and installing the ANITA side stream, which is really, really exciting. So I'd just like to give you a bit of an overview of where we came from and where we're at now. So as you're all aware, AnammoX is a quite mature process. There's plenty of installations overseas, as remain demonstrated. Unfortunately, the importation of the bacterial sludge into Australia is prohibited due to our strict laws. So our only solution for its implementation was basically to grow our own. So this all started, the scale-up process all started back at about 7 years ago, as part of the Innovation Centre. So the Innovation Centre is basically our research centre where we, it's where it enables us to partner with technology providers, Veolia, obviously a perfect example, and universities. And it really is revolutionising the way that we do business, and assisting in the uptake of new technologies. And so through the Innovation Centre and the R&D team, with support from Veolia, we've been heading through this upscaling process, where we started from quite a small amount and working our way up to provide that viable seed for the full-scale instrumentation installation. So obviously being responsible for growing the bacteria, I also get all the experiences and all the joy that comes with that responsibility, and running the biofarms on an operational plant definitely has its challenges too. I don't think there's a challenge that we haven't been kind of thrown at. As you can see on the picture there, that's actually the channel where we take the centrate from. And unfortunately, we were actually, during this upscaling process, we were actually upgrading our dewatering system at the same time. So we had plenty of issues with high polymer, high TSS, and mechanical breakdowns, no centrate supply. So we basically threw everything at this technology. And while this was challenging, working with an operating plant, it really did give us confidence in the technology, in the AnitaMox technology. And it provided us, it really built our knowledge and built that really strong connection between our operators, because it was a really positive, it's been a really positive experience, both the upskilling within the organisation and the better understanding of those process impacts. So last year we engaged Veolia for the design and construct of the 50 metre cube biofarm. So this is the final step in that enrichment process. So the biofarm, fortunately enough, I had graduate engineers at the time. They were so kindly donated their time to help me transfer about 200 buckets, 220 litre buckets of biomass from my previous little biofarm tanks to the 50 cube biofarm. And this was fully commissioned in about October last year, and we're currently on track to be fully ready, to be fully seeded prior to the commissioning of the full-scale plant. So the purpose, the objectives of the 50 cube biofarm is essentially to provide that sufficient biomass. And as you can see from Roman's presentation, the success and the speed of the startup is really comes down to that, having that initial biomass to help with that startup process. But it's also provided other really good things, such as the upskilling the operators, getting them involved with this smaller operation, and just to try and work out and build that confidence within the team. But the other thing, sorry, I forgot to mention, was we have been able to look at the operation of the plant under no heating, and also without the need for mixers for that startup period, which we've been able to successfully do. So the current operation of the plant, so we seeded with about 4 cubic meters of carriers. We're currently at the full loading volume, carrier loading volume, and the plant is reaching loading rates of up to 40 kilograms of nitrogen per day at about 85 to 90% removal. So as you can see, we had quite a rapid startup during the summer months. Unfortunately, during February, we had a big rain event, and essentially the biofarm was fed with rainwater because the centrifuges were turned off and water was being pumped into that centrotunnel. And so essentially removed all ammonia, so all the food for the bacteria, and it experienced incredibly high DOs, and this was for an extended period during the night. But as you can see, it bounced back pretty quick. Not as quickly as what we saw during the warmer months, because as I mentioned, we don't have heating on this biofarm, but we're basically seeing really good sustained removal rates now, and we're basically at the end of the seeding process. And sorry, this is just to demonstrate that really good removal rate that we were seeing between that 85 and 90% of ammonia. So where are we at now? So we're currently in the stages of the delivery for the ANITA Mox sidestream project. So this has been assigned a part of our frameworks. So the design's been finalised, equipment delivered to site just recently, and the works has commenced for the balance of plant construction with our delivery partners, Fulton Hogan. And so we're forecasting commissioning at the end of 2020, which is really, really exciting. So the design of the ANITA Mox sidestream, so we're currently using, or we're retrofitting essentially old pre-aeration tanks. So that's obviously the benefit of using a carrier-based process. So we're able to utilise existing assets. And during the design process, we were able to save some significant costs by looking at the removal of mixers and also providing no heating, which we have established is perfectly fine for that startup and also the operation with the biofarm. And it was really good to be able to work with Veolia. Veolia provided a really good creative hydraulic design, which allowed the tanks to be run in series, which gives it that greater stability, lower effluent concentration, and really does help with improved startup by able to seed those front tanks, and then any bacteria that sloth sulfur grows within that first tank then allows to seed the carriers in the second tank. So the design of the outcome, the process design, so we're expecting the reactor volume is about 1 meg. We're expecting to treat just about 1 meg a day. With achieving that 85% removal, we should see a massive reduction of 850 kilos of nitrogen per day. So this is anticipated to provide significant cost savings of up to $500,000 a year, primarily to do with reduced ethanol dosing. And the next exciting thing is that this will actually be able to be used as a biofarm to help other utilities if they wish to take up this technology. And it really does help with that startup process to really kickstart the actual process. So overall, this is a really great project that I'm really happy to be involved in. So essentially, what AnammoX does for us is it allows us to utilise existing assets, which enables us to unlock capacity within our plant. It also does, because it is a relatively new technology within Australia, it gives us a better understanding. It gives the business confidence of being able to pursue some of these emerging technologies, which ultimately does provide better outcomes for our business and also the customers and the environment. And with that, we should be seeing significant reduction in the cost of treatment. And through this upscaling process, although it's been a long period, it really has supported the development of skills within our organisation, so that we should be really confident in running the full-scale installation and achieving and being able to realise all the benefits that come from the installation or installing an ANITA plant. So finally, I'd just like to thank everyone that's been involved with the project so far. The research and development team, the operators at Luggage Point, infrastructure delivery and procurement, University Technology, and in particular, Veolia Water Technology, who've been really integral to the delivery and support to get this project off the ground.
So thank you very much, Justin. That was a great presentation. So in conclusion, AnitaMox, it's finally here. And as Justin said, the full-scale treatment plant at Luggage Point will be run as a biofarm, so there'll be seed available for other plants. And as I mentioned at the start, and both Romain and Justin have said, it's an organic, it's a sustainable process. So you're going to see a lot of benefits, not just financial, environmental as well. It's very easy to install. We really understand what we're doing now. And it makes a lot of financial sense to install at a wastewater treatment plant. So it's really worth looking at. I'm your contact if you're interested in AnitaMox and like to talk to me any more about potentially looking at your particular application or your treatment plant. I'd love to talk to you, so please drop me an email and I can call you and we can have a chat.